So again, Professor Sargent here with you for another Math 101 Click Classroom lesson. This is on section 2.6. We're going to take a slightly deeper look at functions, about how we write functions, i.e. function notation, and linear functions. So what do I mean by linear functions? First we'll deal with function notation and then get to that. So first of all, when we have a relation that is a function, if we replace y with this notation, f parenthesis x parenthesis, let's write as f of x or f at x. And in my way of putting things, f of x is just a fancy stand-in for y. So that would mean that if we know one of the ordered pairs in the function is x comma y, we could be writing that as x comma f of x instead. Furthermore, y is called the dependent variable. It's depending on x. X is the independent variable. When you are asked to evaluate a function, that means to put in a number for x, wherever you see x in the formula, if we have an equation for the function, and do some calculation. There's no algebra involved in that case, so I want to make it clear that what f of x stands for is just a fancy stand-in for y. This does not get read as f times x. That is not what it means. And one last introductory item here is that we've already seen from considering the vertical line test that a vertical line itself is not an example of a function. That's because if any vertical line crosses the graph of a relation more than once, then it's a relation which is not a function. And in the case of a vertical line, then we have the vertical line that would cross more than once is itself. For the time being, most of our attention is going to be on functions that are linear. And it's worth taking a look here at page 213. Mostly we're talking about diagonal lines. That a right there could be written instead. We could write f of x equals mx plus b. If the slope is 0, we know that gives us a horizontal line. Instead of calling that a linear function, then we have a constant function. Notice also here the information about domains and ranges. You can multiply x by anything, and you can add anything to that and get unique answers, so the domain is all real numbers. In fact, the range of a diagonal line is also negative infinity to infinity with parentheses there, so we can get all real numbers. However, if it is a horizontal line, although x can be anything, the y value is locked in at that number b, and so you use the curly Q braces for that finite set, not interval notation. Not interval notation. To evaluate a function means to take what we see in the parentheses here, usually a number, but not always, replace x in the formula with that, and do a calculation. Evaluates, calculates. And we have to do our calculations according to the order of operations. So, f of 1, or f at 1, we would have the x here. It only shows up in one spot. So f at 1, replace the x in the formula with 1, and that's going to have negative 5 times 1, multiplication before addition, negative 5, so negative 5 plus 2 is negative 3. I'm also going to show that on the calculator, negative 5 times 1 plus 2. The TI-30s, they know the order of operations. Don't use the minus sign, use the negative sign. Negative 5 times 1 plus 2 is negative 3. Okay, so on to the second part. Well, now we're supposed to put in 1/2 instead. Since we are given x as a fraction, they are probably expecting we leave our answer as a fraction. Negative 5 times 1/2 would be negative 5 halves. We can rewrite the 2 with a common denominator. Think of 2 as 2 over 1, multiply top and bottom by 2. And that would be adding 4 halves. So we should get an answer of negative 1/2. And let's check that on the calculator. Put in 1/2 instead of 1. Now that's expressing it as a decimal, but there's a way to convert that back. Let me take a moment to find that. So notice above table in green, F and D with these two directional arrows here. That means converting back and forth between decimals and fractions. So now we have negative 1/2. All right, so let's see the next part. Plug in negative 0.2 for x. Since that is given as a decimal, then it should be acceptable to write our answer in decimal form. Negative 0.2. Negative times a negative is going to give us positive. And it should be that that's just 1. So 1 plus 2 is positive 3. Let's check that. So putting in negative 0.2. negative sign, not minus sign. And add 2 again. There's our answer of positive 3 as expected. This fourth one, instead of putting in a number, we're putting in another expression. So our answer, when we evaluate, is going to be an expression. Got x plus 1 replacing x. And what that's going to look like. Throughout all this other stuff. I could have done this in the previous parts as well, but notice this time how I've highlighted in red what is replacing x. So, instead of x, parentheses around that, because there are 2 terms to that, put in negative x plus 1 instead, and simplify that. By distributing. Okay. Distribute the negative 5 to the negative x plus 1. Negative 5 times negative x will give us 5x. Negative 5 times positive 1 will give us minus 5. And then combined like terms, we'll have 5x plus 3. Unfortunately, the TI-30 is not going to let us check that. Future starts cutting in here. Although I could not check that last one with a calculator, I did catch an error. Negative 5 plus 2 is negative 3. So instead of 5x plus 3, that should be 5x minus 3. Take note of that. When we go back to past Sarge, we're going to be seeing the typo still there, but this is what it should be. Now we have a different function. I could have also named that f of x, but because I'm dealing with 2 different functions in the same video here, I've named this one differently, g of x. And when it's asking us to evaluate g at negative 3, i.e. f of g of negative 3, then since we have in 2 places here, I have to replace it in those 2 places with negative 3. And if you like the color coding, let me do that. Now notice I put parentheses around it because I did that because it's negative. Negative 3 squared, same as negative 3 times negative 3, is going to be positive 9. That's minus sign that's in front of that, or negative sign. It's like saying negative 1 times that. So even though I get positive 9 here, the next thing I'd have to do is multiply it by negative 1. So we've got negative 1 times 9, plus 4 times negative 3, plus 2. And that's going to give me negative 9 minus 12, same as plus negative 12, and then plus 2. I'm multiplying before I do any adding or subtracting. And what that gives us is negative 21 plus 2, negative 19. Sign did not show up. Negative 21, negative 21 plus 2 is negative 19. Checking that on the calculator. We have negative 1 times negative 3 squared. Squared is right there. Plus 4 times negative 3 and plus 2. There's our negative 19 as expected. And one more to this part. Now they want us to put in 0.5. And again, since that is a decimal, that should be okay to give a decimal answer. And I'm just going to go ahead and put that straight in the calculator. So I can, on this newest version of the TI-30, scroll back, copy and paste, and let's see, we needed positive 0.5. I'm just put 0.5. That's the same as 0.5. Again, I'm doing that in both places. Erase some stuff after that. There we go. Now we're getting 3.75 for our answer. One more piece of information to this section. Whatever the graph of f of x equals negative 5x plus 2 looks like, by doing this evaluation, that would tell us that point 1 comma negative 3 would be on the graph of y equals f of x. Down here, 1/2 comma negative 1/2 be on the graph. Negative 0.2 comma 3 be on the graph. For D, that wouldn't provide me any information. And then whatever the graph of y equals p of x looks like here, negative 3 comma negative 19 will be on the graph. And 0.5 comma 3.75 will be on the graph. That's because f of x, or whatever we've named the function, is a fancy stand-in for y. And when you evaluate the function, then you are just finding out the y coordinate for the corresponding x coordinate that you have plugged in. At this point, we're going to check out a few questions on the MyLab homework. And this question goes back to what I said at the beginning. Since f of x is a fancy stand-in for y, then x comma y is x comma f of x. This is also reversing the last thing I showed on what I was typing, that when you evaluate f of x and you get an answer, that's actually an answer for y. So I was stating what points would be on the graph of those functions. So f of negative 2. We look up here for where x is negative 2 in the ordered pair. That shows up in the first one. And the y coordinate that goes along with that is 7. So f of negative 2 is 7. Whereas when they ask for f of 7, we see the x coordinate 7 in the second ordered pair, and it is also paired up with a y coordinate of 7. So f of 7 is equal to 7. This is just written differently. It's still giving us x comma y ordered pairs, but in a table. So f of negative 4 is paired up with y equals 9. So f of negative 4 equals 9. And f of 4 is paired up with y equals 15. So f of 4 equals 15. And then when we see this graphically, we have a graph of a line. And as was mentioned towards the beginning, then that's a linear function. And f of negative 1. When x is negative 1, it looks like y is negative 3. Which makes f of negative 1 equal negative 3. Whereas when x is 1, trace down vertically again, looks like we've got that, okay, I guess it's 1 unit above it. So let me try negative 4 then. Okay. Now here they're not asking us to put in a value for x. They're telling us that we have obtained a y value of negative 5. So let me enlarge this. When y is negative 5, okay, when y is negative 5, it looks like it's matching up with x equaling 1. When y is equal to negative 3, looks like it's matching up with x equaling 0. When y is negative 1, looks like it's matching up with y equals negative 1. It looks like we're getting x equals negative 1. All right. Since I haven't opened up anything to type or write some stuff somewhere, I'm going to type out my work and then erase the work, get to the final answer. If we subtract x from both sides here, we'll have 4y equals negative x plus 15. And then if I divide by 4, I will have y alone. And we'll get rid of that extra equal sign. That may actually be enough. However, since that is now in y equals mx plus b, and we're replacing y with f of x, they may want us to put this in slope-intercept form. So that would be negative 1/4 times x plus 15 quarters. As long as we have a slope of negative 1/4 and a y-intercept at 0, 15 quarters. Let's see if it takes that. Yes. Now, whether I actually had to distribute that division by 4 or not, I did not check that. They may have accepted the first version of the answer. So plugging in 14 for x, so leave that as 14/4 though, because of what we have to add it to. It's also having its sign chain. So negative 14/4 plus 15/4 will give us 1/4. Notice I'm not converting that to 0.25 because they want us to type an integer or a fraction. Checking that answer. There we go. To graph f of x equals negative 5x plus 2. That's really saying that y equals negative 5x plus 2. So I would plot the y-intercept at 0, 2, and use slope to go down 5 units, and right 1. I'll be at 1, negative 3. Saving it, and checking the answer. Although the arrows are not being shown, they are technically there, and so we have all real numbers for both the domain and the range. So negative infinity, positive infinity. I don't have to type the plus. I do need the parentheses though, not square brackets, because you cannot actually get to those. They're not numbers. And I just did a little copy so that I could put the range as the same. Notice that I'm not putting that interval notation in the curly Q braces either. And that's good. This is going to be y equals negative 3, horizontal line. So I can plot the y-intercept at 0, -3, and then any other point, such as 3, -3. It wasn't showing up in the portion of the screen I'm sharing, but remember to watch the upper right-hand corner to make sure before you click that it's showing the coordinates that you're trying to plot at. The domain, all real numbers. The range, however, y is locked in, it's fixed at -3. And this time I do type it in the curly cube braces because it's finitely many things that y could equal, rather than some inequality being satisfied that would demand using interval notation. And finally, we told a small bicycle manufacturer has daily fixed cost of $1,930, and each bicycle costs $78 to manufacture. Let X represent the number of bicycles manufactured, and C of X represent the cost of manufacture. So this would be talking about the daily cost. We have cost per bike times number of bikes, plus the fixed costs, which do not rely on X. When we plug in 78 times 6, let me check what that is. 78 times 6 is 468, and I'm going to add to that 1,930, so that the total cost in a day, if they manufacture 6 bikes, is, so the cost of manufacturing 6 bikes is $2,398. They've already got the dollar sign type for us. If, on the other hand, we know that the cost was $2,632, we're solving for X. That means that we are looking for how many bicycles were manufactured for that cost. I expect, since the cost is more than what we found in part B, then I expect more bikes are being manufactured. So, what I would be doing, again, I'm going to use this space to type out some work and then erase some stuff. 2632 equals 78x plus 1930. I'm going to subtract 1930 from 2632, which gives me 702. That's going to equal 78x. And dividing that by 78, I'm getting 9. So x equals 9. We've already got the x equal part typed in there. That means that to manufacture 9 bicycles in a day, that cost for that day would be $2,632. F of -8 equals 9. Whereas here, f of x equals 12, they're giving us y. Track back to x equals 4. We are told that this is a linear function, and the way that we can tell that is that as the y values keep going up by 1, the x coordinates keep going up by 4. That's actually the slope. And so the y-intercept, they do give us when x equals 0, the y is 11. So remember, 11 is just the y-coordinate of the y-intercept. When we want to state the y-intercept, we want to state the ordered pair, even if they hadn't told us that. And now that we know both that the slope is 1/4 and that the y-coordinate of the y-intercept is 11, here's our equation for the function, our equation for the line. The independent variable is going from 0 to 125. They're allowing for all possible values in between. So x is greater than or equal to 0, less than or equal to 125. Because of the or equal to's, we're including those endpoints. So I'll have square brackets. Be careful there, I typed the period instead of a comma. Now it's good. And then the dependent variable is running as low as 0 on up to 3,000. Remember, the dependent variable is y. For how many hours is the water level increasing? Meaning, as we go left to right, that the y values are going up. And that's for 50 hours. 0 to 50, so 50 hours. And decreasing, we only see it going down from 75 to 100, so 25 of those hours. How many gallons are in the pool after 60 hours? After 60 hours, well, they don't show exactly 60, but that's between 50 and 75, and it's staying constant in between there. So we still have to be 3,000 at 60 hours as well. F of 0 is 0. That means that the pool is empty, meaning there are 0 gallons at 0 hours times 0. Whereas f of 50 Y, when X is 50, that's 3,000. So that means that there are 3,000 gallons in the pool after 50 hours. And that's all I have for now. Hope this helps, and I'll see you in class.